So I'm going to do this one two different ways. I'm going to do it by hand to start off. By hand first. Then I'll do it in the calculator. Well, look at that line, it says negative 4z is 20. And if I just solve for that, I get z is negative 5 because I divide both sides by negative 4. Then I'm going to take that and I'm going to plug it in to the first equation. And I'll have negative 2x plus 3y minus 25 equals negative 21. And I'm going to add 25 to both sides, and I'll get 4. So let's see what we got here. We have a line, I'm looking at equation 3 right here. It says 6x minus 3y equals 0. And I have this equation that I just derived a little bit. Negative 2x plus 3y equals 4. And what I'm going to do is I'm just going to add down. Because if I add down, I notice that my y's disappear. And I'll have 4x, there will be no y, and it'll equal 4, and x is 1. And now that I have x, I can just plug it in. I'm going to go for equation 3 here. 6 ones minus a 3y must be a 0. 6 minus 3y must be a 0. Negative 3y must be negative 6, and y must be 2. I'm going to represent my answers as an ordered triple. An ordered triple will go x, y, z. I came up with x being 1, y being 2, and z being negative 5. So that's how I do it by hand. We did matrices. So the other way I can do this is I can use matrices. I can create an augmented matrix that contains, and when you do the augmented matrix, you have to be careful about, placeholders and stuff. But line 1 is negative 2, 3, 5, negative 21. Line 2 has no x, it has no y, it has a negative 4z, and it's 20 on the other side. Line 3 is a 6, a negative 3, no z, and a 0. I don't know if you remember what this is called or not, but this guy right here is called the augmented matrix. There you go. There's your augmented matrix. Now what I'm going to do is I'm going to put this in a calculator. I'm going to hit second matrix. I'm going to scroll to edit. I'm going to choose matrix A. And I'm just going to, which by the way has 3 rows, 4 columns. So 3 by 4. And I'm going to enter this data in. So give me just a second, I'll do that. The problem with firing up my calculator here is that I can now no longer write properly. Something happens when this calculator gets fired and I can't write anymore. Again, the keypads on this were second matrix, scroll to edit, choose A. She is a 3 by 4. She has 3 rows. She has 4 columns. Then you just type the stuff in. And you ought to be able to keep up with me at home. I'm having to use my mouse cursor. I'm tired. Should have 0 issues keeping up with this. Of course, the issue is most of you don't have calculators yet because you have not gone and seen the librarian. Because you're afraid you'll lose it. And then you'll have to pay the library back. Or, and you could just hear me out, you could just not use the calculator and you could have something at home so that you could do your mathematics. All right, since the stuff is in here, I'm going to do a second quit. Then I'm going to press the matrix button. I'm going to scroll to math. I'm going to scroll down to a function called RREF, which is 2 below cum sum if you forgot. Press enter. So I quit. I go to second matrix, go to math. I'm looking for that function called double REF. I press enter. And I'm going to tell it to use matrix A. Second matrix. I did everything in A. It's going there. Enter, enter. And this is what's returned. You know, a couple of you guys probably don't remember what this is. Ty Bizzle not going to watch this video, but this is for him. Kids like him. The top line says 1x is 1, so x is 1, which is what we came up with earlier. Bottom line, the second line says 1y is 2, so y is 2. And the third line says 1z is negative 5, so z is negative 5. Which is exactly what we had earlier as an ordered triple. So that's how you do that one. The factoring section. A couple of these I'm going to mention the patterns that they are, and I'm also going to make things simpler. This one right here happens to be an a squared minus b squared pattern, which means that she factors as a minus b times a plus b. And I'm going to make the numbers smaller too. I know that both pieces are divisible by 9, so I'm going to pull it. That'll leave me with x squared minus 4 on the inside. And when I do that, a is x and b is 2, because x squared is x squared and 2 squared is 4. I'm just going to follow my pattern. There's a 9 out front. I have x minus 2 and x plus 2. And that's how you factor number 4. All right. 4 was a special pattern. 5 is not a special pattern. 5 is just basic factoring. You're going to need a z and a z to make a z squared. And since it's just 1z squared, I need factors of negative 9 that add, of 9, positive 9, that add to negative 10. And they happen to be negative 1 and negative 9. Because a negative 9 plus a negative 1 is negative 10. That's what I'm thinking for those of you who can't factor. And negative 9 times negative 1 is positive 9 at the end. So again, this is how that one factors. Let's see, 6 is going to be a little harder. You're going to guess and check. That's what you're going to do. Thankfully, there's only one way to make a 7n squared. It takes a 7n and an n. And we want to arrange so that we add to a negative 32. I'm going to guess I'm going to need a 10 here and a 6 here. I want to be a negative 32. That's the sign there. That's the sign there. Because positive 10 times negative 6 is negative 60. And when I do the guess and check here, 7n times negative 6 plus 10 times n is negative 32n. So I'm guessing and I'm checking, kids. That's what I'm doing. That's why it works. All right, what's 7? 7's kind of funky. X to the 2n minus 5n plus 6 is supposed to be factored. This has a typo, and I need to fix that. That little piece is supposed to be minus 5 to the n. That's what that little piece is supposed to be. So that needs to be something that I fix. There we go. Now, it takes an x to the n and an x to the n to make x to the 2n. I'll explain that in just a minute. Why does that work? Because x to the n times x to the n is x to the 2n, because we add exponents when we multiply. All right, factors of 6 that add to negative 5 are probably going to be, and it's a positive 6, isn't it? Negative 2 and negative 3. Get out of the exponential space there. And that holds. Negative 2 times negative 3 is positive 6. Negative 2xn minus 3xn is negative 5 to the n. So she's done. It wasn't that bad. 8 is x to the 4th. You should be aware of by now that it takes an x squared and an x squared to make x to the 4th. Lord help you if you're not. And I want factors of negative 4 that add to negative 3. That's going to be a minus 4 and a plus 1. And here's the thing about this one. It's not done. This is factoring. You don't stop factoring until you're done. X squared minus 4 is a lot like the first example, a squared minus b squared. It factors as x minus 2 times x plus 2. X squared plus 1 does not, shall not factor. In fact, it doesn't even have any real answers if it was set equal to 0. All right, that's how she factors. And now we're moving on to number 9. Isn't that funky looking? Number 9 is probably factoring by grouping. I am going to focus on the first two pieces and see what I can pull. I'm pretty sure I can pull a 4, and it looks like they both have an x. And if I pull a 4x from 12xy, I'm left with 3y. And if I pull a 4 from 28, I have a 7, and I pulled the x. Minus because there's a minus. 15 and 35 are both divisible by 5. If I pull a 5 from 15, I have a 3. There's a y there. If I pull a 5 and negative 5 at that from 35, there is a minus 7. The common factor is 3y minus 7, and the stuff left over is 4x minus 5. Number 10. 10's got one of my favorite patterns. I like this pattern. 10 is the a cubed plus b cubed pattern. Any a cubed plus b cubed in existence factors as a plus b times a to the second minus ab plus b squared. You just have to pick out your a's and b's and plug them in. A is 2x, because 2x times 2x times 2x is 8x cubed. B is 3, because 3 times 3 times 3 is 27. So everywhere I see an a, I'm a 2x, and everywhere I see a b, I'm a 3. If I take a 2x and I square it, I get 4x to the second, minus, because there's a minus, 2x times 3 is 6x, plus, because there's a plus, 3 squared is 9. Done. All right, what's 11? 11, I'm going to change the order and make it 125 minus 27. I think that's a u. U to the cubed. The reason I did that is because that made it look like a cubed minus b cubed. It factors very similar to the last one. It's a minus b times a squared minus ab. Oops, not minus. Plus ab plus b squared. Notice I just know my formulas. Here a is 5 and b is negative. Sorry, not negative, just 3u. The form over here, it counts for all your signs. So don't try and make this harder than it is. Everywhere you see an a, you're a 5. Everywhere you see a b, you're a 3u. 5 squared is 25. 3 times 5 is going to be 15, don't forget the u. And a 3u times a 3u is 9u squared. And I'm almost done with the factoring section. Here we're going to follow commandment number 1 of math, which is if you can pull it, pull it. So we're going to pull some stuff. And what we're going to do is we're going to pull a 2 and an x. The reason I'm pulling a 2 and an x is because I'm about to create a sum of 2 cubes pattern. So look at that x cubed plus 64. A is x because x times x times x is 8 cubed. B is 4. 4 times 4 times 4 is 64. And I'm going to assume you still got that formula. It's a lot like this one, except this is a plus and that's a minus. If I take an x and I square it, I'll have x to the second. Sorry, I forgot the first thing. X plus 4. Now I've got to square it. There should be a minus symbol here for the sum of 2 cubes. A times b, x times 4, 4x, plus b squared, 16. And there's the factoring section, kids. Hope you understood it. 13, we got the quadratic formula. And I'm going to have to write because this thing will not type out the quadratic formula. It says solve it. I need to edit this so it says equal to 0. Apparently this doesn't factor. So if I glance at it, I know that a is 5. I know that b is negative 12. I know that c is 6. I'm not going to give you the formula. I'm not going to give you the sum. You need to be memorizing it. It's x equals negative b plus or minus square root b squared minus 4ac all over 2a. I'm just going to plug into that thing and go to town with it. Opposite of a negative 12 is a positive 12. Plus or minus square root. If you're going to square a negative, you just drop the negative symbol because it's going to be positive automatically. Minus 4 times a, which was 5, times c, which is 6. And it's all over, not just part of it, all of it, 2 times 5. Now in this radical is going to be 144 minus something. All right, I'll show you all the steps. Some kids can't evaluate the radical. 4 times 5 is 20, times 6 is 120. So 12 plus or minus. 2 times 5 is 10, both pieces over at 10. 12 tenths is going to be 6 fifths. Everything's said and done. Plus or minus in the radical, 144 minus 20 is 24 over 10. And now in some far-fetched corner of my brain, I think about root 24. She is the root of 6 times 4. The root of 4 is 2. That was evaluated, goes out front. 2 root 6. So I've got 2 root 6 over 10, which is root 6 over 5. 6 fifths plus or minus root 6 over 5. Final answer. If I wanted the decimals, you evaluate that in a calculator, but I don't want the decimals. All right, moving on to this one. 14. Find all real zeros, your x-intercepts, and state their multiplicity. This is the zero product property. I'll type this one out. You're going to use the zero product property, and you're going to set each factor equal to 0. So the first one is 3x equals 0. If you divide by 3x is 0. The multiplicity is the exponent on the x. That hadn't understood 1. So the multiplicity is 1. The next factor you have is x plus 3, and you're going to set it equal to 0. If you shift your 3 over, you get negative 3. This factor had an exponent of 1. The multiplicity is 1. Now I see x minus 4 squared, and it's equal to 0. Just take the stuff inside, set it equal to 0, x equals 4. Its multiplicity is 2. Its multiplicity is 2 because she had an exponent of 2. Now pay attention that I only want real zeros, all right? The next factor I see is x squared plus 7. Now, anybody who knows math who's watching this video is probably wondering why I'm doing the work. I'm doing the work because my juniors do not math. I'm going to shift the 7 over. It's going to make it negative. I'm going to counteract the squaring with a square root. And I'm going to get plus or minus the imaginary root of 7. I don't have a square root symbol on this calculator. This is not real. On a multiple choice test, you would not talk about that answer. These are the answers we're after. That one, and that one. That being said, there was some math I did here that you need to make sure you didn't understand. All right, 15. Let some 8th degree polynomial have a leading coefficient of 3 in the following zeros. Write it in factored form. All right, so let's talk about these. If you have a 0 of 0, your factor is x. Because your multiplicity is 2, see that 2? It's x to the second. If you have a 0 at 2, your factor is x minus 2. Now, because we have a multiplicity of 2, we have to have an exponent of, take a guess, 2. Ah, look at this one. Negative 2i is a 0. By the complex conjugate theorem, positive 2i is also a 0. So our two factors are x minus a negative 2i, which is x plus 2i, and x minus 2i. Notice I'm changing signs as I enter parentheses, 2 minus 2, negative 2i becomes plus 2i, and so forth. And the multiplicity is 1, so these both have understood exponents of 1. Now we have 2 minus root 2 is a 0. By the irrational conjugate theorem, 2 plus squirt 2 is also 0. So the factors here, and when we enter parentheses, we just change sign, will be x minus 2, because I changed that 2 sign, plus a squirt of 2. And by the way, please don't be the kid who writes squirt. And the other one's going to be x minus 2, and in this case, plus becomes a negative, minus squirt 2. And again, don't be the kid who writes squirt. Use the square root symbol. I am typing. All right, what do we know here? We have a leading coefficient of 3. So when I start writing this function, I have a 3. Leading coefficient of 3, right up there in the text. Leading coefficient of 3. Then I'm just going to write down my factors. All right. The first factor was x to the second. The next factor is x minus 2 to the second. The next factor is x plus 2i, followed by x minus 2i. And the last one is these funky ones. X minus 2 plus squirt 2. And x minus 2 minus squirt 2. There you go. That's number 15. I'm going to go ahead and stop this video so it doesn't get so blasted long. I never started this video, did I? Good, I did.